Hello, welcome students. Let us continue with some more examples on Fourier series. But in this example, we are going to find Fourier series of given function in some different interval, that is 0 to 2 pi. याच्या पूर्वीची एक्झाम्पल्स आपण जी केलीत त्याच्यामध्ये इंटरवल आपण मोस्टली -π to π घेतली होती. आता आपण इंटरवल चेंज करतो जस्ट फॉर प्रॅक्टिस. अगदी सेम मेथड आहे. फॉर्म्युल्यामध्ये फक्त इंटिग्रेशनचं जो लोअर आणि अप्पर लिमिट आहे ते दिलेल्या इंटरवल प्रमाणे आपल्याला लोअर लिमिट आणि अप्पर लिमिट रिप्लेस करावं लागेल एवढंच. ओके, सो एक्झाम्पल, फाइंड Fourier series of f of x in the interval 0 to 2 pi, where function is defined like this: f of x is equal to x, total interval is 0 to 2 pi, means x varies from 0 to 2 pi, and within this range first x varies from 0 to pi. When x takes these values 0 to pi, f of x is defined to be x. Okay, I mean when x is equal to pi by 2, find image, we will use this function because pi by 2 is in between 0 and pi. It lies between 0 and pi. So first definition, first part of the definition, you may call it as first piece of the definition of function. Okay, so and for a remaining part 0 to pi we covered it in this f of x is equal to x, and when x takes values from pi to 2 pi, that is x lies between pi to 2 pi, then function is defined to be 0. सो अशा फंक्शनला आपण पीस वाईज किंवा आता ते कंटिन्युअस आहे म्हणून ठीक आहे, पीस वाईज कंटिन्युअस फंक्शन असं म्हणू शकतो. अशा पद्धतीच्या फंक्शनसाठी तुम्ही लॅपलास ट्रान्सफॉर्म वगैरे डिटरमाइन केलेला आहात. सो यू नो व्हॉट टू डू द इंटिग्रेशन 0 to 2 pi. As it is defined in two parts 0 to pi, we break this integration into two parts: integration 0 to pi plus and then integration pi to 2 pi. That addition will give you total integration from 0 to 2 pi. Okay, well, मागे जी एक्झाम्पलमध्ये आपण केलं तशाच पद्धतीनं आपण फक्त इथं फोरियर कोइफिशियंटच्या ज्या व्हॅल्यूज आहेत त्या आपण फाइंड आउट करू. दॅट इज ए नॉट, ए एन आणि बी एन. वी विल ओनली फाइंड फोरियर कोइफिशियंट्स. ओके, actual Fourier series we are not going to find full Fourier series because it is easy to replace those values. So my first value is a naught, and by formula for Fourier series in this interval 0 to 2 pi, that is already given to you, it is 1 upon pi integration, instead of minus pi to pi we have to take 0 to 2 pi. Okay, into f of x dx. Well, let us substitute the value of f of x, but you know that f of x is divided into two parts according to your x, means domain interval. So our total domain interval is 0 to 2 pi, which is divided into two parts 0 to pi and pi to 2 pi. Therefore, to evaluate this integral we divide it into two parts: one integration from 0 to pi and then other integration from next half part pi to 2 pi. Okay, and accordingly ज्या पद्धतीने तुमची ती इंटरवल असेल त्याप्रमाणे आपण फंक्शनची डेफिनेशन पुटअप करणार. इन फर्स्ट इंटिग्रेशन 0 to pi, so x lies between 0 to pi, I have to use this part. In that part f of x is x, so f of x is equal to x in the interval 0 to pi. Accordingly I will take integration, and in the remaining part pi to 2 pi, f of x is defined to be 0, so integration of 0. Okay, I hope you get this. Now just evaluate those integrals. Obviously integration of 0 is 0, so no need to consider second integral, only evaluate the first part, integration of x. Integration of x is x square by 2 and lower limit is now 0, upper limit is pi. Only this integral. Second integration is 0, so forget it. Therefore, a naught is equal to, now as usual, replacing upper and lower limit, x equal to pi x square, pi square upon 2 minus, for lower limit x equal to 0, 0 square is 0, so it is 0. Just a matter of simplification. 1 pi get cancelled and finally we get value of a naught as pi by 2. Okay. Now let us find out the value of an. Again, formula for an is integrate, sorry, 1 upon pi integration. Now my interval is 0 to 2 pi f of x into cos nx dx. Again, as our function is divided into two parts, 0 to pi and pi to 2 pi, accordingly, just as we did in case of a naught, we will do it here same thing. परत एकदा आपण जसं आपण a naught च्या वेळी इंटिग्रेशन ब्रेक केलं, इथं सुद्धा आपण इंटिग्रेशन ब्रेक करणार. 0 to 2 pi चे दोन भाग आहेत, 0 to pi f of x cos nx plus integration pi to 2 pi second half f of x cos nx. F of x, we have to put f of x accordingly the interval 0 to pi or pi to 2 pi. In first interval 0 to pi, f of x is defined to be x, so I put x here because my x varies from 0 to pi. Integration ची जी limits असतात, integration 0 to pi means x takes values from 0 to pi. It is domain interval actually. Okay. And in second interval pi to 2 pi, f of x is defined to be 0. So again second integration becomes 0. We will only evaluate first integral. So to obtain an, I will have only first integral, consider only first integral, x into cos nx. Again I will use integration by parts, generalized rule. Now, obviously derivative of x is 1 and then derivative of 1 is 0. We will take x as our first function and obviously then second will be cos nx. Use the generalized by parts rule. First as it is, x as it is. Integration of cos nx is sin nx upon n. You know this now. Alternate plus minus, plus now minus. Now this is first and this is second. Derivative of first, derivative of x is 1 and integration of second, denominator n constant as it is. Integration of sin nx is minus cos nx upon n. So 2 n's at denominator in multiplication. So n into n, we get n square. Now you are familiar with all this type of calculation. For next term, derivative of 1 becomes 0. So we will not write next term, further terms. Okay. So only matter to check what are the limits of integration. Integration 0 to pi. So this part has limits 0 and pi. Now we put upper limit minus lower limit. For x is equal to pi, in first term we get sin n pi, but sin n pi is 0. Okay, so sin n pi 0. Whatever x is pi, pi into 0, 0. Second term minus minus plus, and when we put x is equal to pi, cos n pi, as I told you earlier, cos n pi is minus 1 raised to n. denominator n square as it is. This is for upper limit minus lower limit. When x is equal to 0, this part is 0, 0 into sine 0, again 0, again first part is 0, first term is 0 for lower limit x equal to 0. And when we put x is equal to 0 in second, minus minus again plus, cos 0 is 1, denominator n square again as it is. This is it, upper limit minus lower limit. Okay, so after simplification we can take this denominator n square common, n square at denominator common. Obviously at a numerator, in this term we are left with minus 1 raised to n, middle sign is minus, minus plus minus again, and numerator of this second term is again 1. So minus 1 raised to n minus 1. Okay, so this is the answer for an. Let us go for bn. Now last Fourier coefficient, bn is equal to, again the formula is 1 upon pi integration 0 to 2 pi, because now domain interval is given to be 0 to 2 pi. For bn, integration of f of x into sine nx. This is the formula for bn in the interval 0 to 2 pi. Again we evaluate in same manner, as our function f of x is defined in two parts. In 0 to pi it is x, in pi to 2 pi it is 0. Okay, so accordingly we break the integration. Now I will not put bracket. Integration 0 to pi, and in this part 0 to pi, f of x is defined to be x, sin nx as it is dx, plus in for second integration pi to 2 pi, f of x is 0, so obviously second integration becomes 0, so I will not write second part of this integration. Okay, so integration pi to 2 pi, 0 into sin nx. Okay, so this integration will become obviously 0, so no need to add 0. Okay, let us simplify this integral only. 1 upon pi, again use generalized by parts rule. First x, second is sine, because derivative of x vanishes early. X as it is, integration of sine. Integration of sine is minus cos nx divided by derivative of nx. Derivative of nx is n. Alternate plus minus. Derivative of x is 1. And again integration of this bracket, minus sign as it is. Integration of cos is sine nx upon n, and this n becomes n square. Okay, I think this much is okay. And for all this, lower limit is 0, upper limit is 1. Okay, I think I should let us write it down properly. Okay, 0 to 5. Now for first we put upper limit, x is equal to pi, outside 1 by pi as it is. Upper limit, when x is equal to pi, x is equal to pi minus negative cos n, and x is equal to pi, so cos n pi. Cos n pi is minus 1 raised to n, denominator n as it is. And when you put x is equal to pi in sine, sin n pi is 0, so second term becomes 0. minus minus plus, it is 0. This is upper limit minus now lower limit. For lower limit, when you put x is equal to 0, this x makes first term 0, 0 into cos, it becomes 0. And when you put x is equal to 0 in sine, sine 0 is 0, so second also 0. So for x is equal to 0, both term gives a value 0. I will write only one 0 for that. And let us simplify bn. We got value of bn like this. You can merge this minus into this, because minus means minus 1 and minus 1 raised to n. So according to laws of indices, first this pi get cancelled. So minus 1 into minus 1 raised to n, minus 1 raised to n plus 1. Pi gets cancelled and denominator n as it is upon n. So this is the value for bn. Okay. Now I think this type of examples are sufficient now. We go to almost last part of this unit or topic, called as half range Fourier series. Sometimes आतापर्यंतचा जो पार्ट होता त्याच्यामध्ये आपण we assume that function is having period 2 pi. So when we consider interval 0 to 2 pi or minus pi to pi, we are having full range. But sometimes we have to expand our function in the interval 0 to pi by considering period 2 pi. Means our period is 2 pi, but our domain interval 0 to pi is half of half length. मग 0 to pi ची लेंथ जी येते ती येते पाय ओनली, आणि ॲक्च्युली पिरियड आपल्याला दिलेला आहे 2 पाय. त्यामुळं पिरियडच्या बरोबर निम्मीच इंटरवल घेतलेली आहे. अशा केसमध्ये रिमेनिंग हाफ इंटरवल जी राहते त्याच्यामध्ये फंक्शन एकतर इव्हन किंवा ऑड पद्धतीनं बिहेव होतंय असं ॲश्युम करतात. जर इव्हन ॲश्युम केलं तर तुम्ही ऑब्विसली bn जो आहे त्यातला फोरियर कोइफिशियंट तो 0 होणार, आणि bn जर 0 झाला तर bn ला फोरियर सिरीज आपली तुम्हाला माहिती आहे a0/2 प्लस समेशन an cos nx plus bn sin nx. So in general, ans are attached with cosine term. This a0 can be treated like a0 into cos 0x. So cos 0 is 1, that's why we don't write a0 cos 0. So we write only a0. So if we consider the function is to be like behaves like even function, then bn becomes 0, then automatically sine terms in that series get eliminated, and we get the series which contain cosine terms alone. त्या सिरीजमध्ये फक्त कॉशस टर्म राहतील, कारण bn हा जो कोइफिशियंट आहे साईनसाठीचा तो 0 होतोय जर आपण इव्हन ॲज्युम केलं तर. ॲक्च्युली ते फंक्शन नाही आहे आपल्याकडे, फक्त हाफ पार्टच आपल्याकडे आहे 0 to पाय, पण रिमेनिंग पार्ट जो आहे त्याच्यामध्ये पण फंक्शन इव्हन किंवा ऑड सारखं ट्रीट करू शकतो. ओके. आणि जर आपण ते फंक्शन ऑड टाईप सिलेक्ट केलं तर मग तुमचा an चा पार्ट जो आहे तो 0 होणार, आणि मग ऑटोमॅटिकली सिरीजमध्ये समेशन bn sin nx सिरीज विल कंटेन टर्म्स ऑफ साइन ओनली. ओके. म्हणजे अशा पद्धतीनं कन्स्ट्रक्शन केल्यानंतर विथ दिस assumption either you can obtain Fourier series containing cos terms only or sine terms only. In such type of series is called half range Fourier series. So expansion of Fourier series with period 2 pi but range is 0 to pi, called as half range Fourier series. In half range Fourier series, जसं मी आता तुम्हाला एक्सप्लेन केलं, function f of x can be expanded as a series containing cosines alone by treating that function as even function, so that bn becomes 0. Okay. जर तसं if that function is expanded in Fourier series with cosine terms only, it is called half range Fourier cosine series. But this is very lengthy, I think, name. So we may simply refer it as only cosine series. So find cosine series means find half range Fourier cosine series. Okay. And similarly, or you can obtain a series containing sines alone called half range Fourier sine series or simply sine series. Under this assumption, we get very important values for those Fourier coefficient. Borobar. As we are going to assume function is expanded only either in terms of cos or only in terms of sine. Again we have to find out the Fourier coefficient. And so this following theorem gives very much important information how to obtain Fourier coefficient according to your nature of half range Fourier series, whether it is Fourier cosine series or Fourier sine series. Theorem. First part gives the values of a0 and an when you assume that function is expanded in half range Fourier cosine series, or you may simply call it as cosine series. So in that case your bn is equal to 0, so function f of x is expanded like this: 1 by 2 a0 plus summation an cos nx. Next term bn, it is assumed to be 0, so no need to write bn sin nx. We are assuming that function is in terms of cosine alone. So in whole Fourier series we get this much part only. Sine part is 0. Okay, vanishes. And if this is your assumption, then value of a0 is given by this formula. Our old formula was a0 is equal to 1 upon pi. Now that becomes a0 is equal to 2 upon pi integration, and as I told in the beginning that we are taking the interval half part only, 0 to pi. So obviously integration from 0 to pi f of x dx. So a0 is equal to 2 by pi integration 0 to pi f of x dx, and an is equal to 2 upon pi integration 0 to pi f of x cos nx. हे फॉर्म्युले अगदी सिमिलर आहेत आपल्या जुन्या फॉर्म्युल्यांबरोबर, पण इंटरवल आता 0 टू पाय असणार आहे आणि हाफ रेंज असेल तर 1 अपॉन पायच्या ऐवजी तुम्हाला कोइफिशियंट बाहेर 2 अपॉन पाय घ्यायचं आहे ए नॉट आणि एन साठी. In case of Fourier sine series, if f of x is expanded in a series of sines, obviously तो साइन मध्ये फॉर्म कसा असणार आहे, a नॉट आणि an are absent now. So f of x is equal to a naught absent, an cos nx absent. So this much series only left. Series bn sin nx. Okay. And in that case, अशा पद्धतीची series जर आपल्याला पाहिजे असेल, we have to find out only one coefficient bn, and bn is given by this formula. Again similar, instead of 1 upon pi we have 2 upon pi. In place of integration minus pi to pi or 0 to 2 pi, we have integration 0 to pi. And for bn, f of x into sin nx, that is almost familiar to you. Okay, so this is formula for bn. If you want to obtain Fourier series, half range Fourier series in sine only. Okay, so at a time कुठला तरी एकच तुम्हाला फॉर्म्युला लागणार, कारण तुम्ही एकतर कोसाइन कडे जाल किंवा साइन कडे याल, दोन्हीपैकी एकच. हाफ रेंज फोरियर साइन सिरीज साठी किंवा हाफ रेंज फोरियर कोसाइन सिरीज साठी. Let us practice one example. Okay, now we are asked to find Fourier sine series, means half range Fourier sine series. Obviously our interval is 0 to pi. Okay, आणि ह्या इंटरवल मध्ये आपल्याला फंक्शन डिफाइन करून द्यायला लागेल, दिलेलं आहे 0 टू पाय मध्ये परत दोन भाग केलेले आहेत. In 0 to pi by 2, when x takes value 0 to pi by 2, f of x is defined to be x. And when x lies between pi by 2 to pi, second part, function is defined to be 0. Okay. Now, we are asked to find half range Fourier sine series. We know that half range Fourier sine series is this. F of x is equal to summation, no a naught, no an, only sine term, sine ratio only. So only bn present, summation bn sin nx. So we have to just find out one Fourier coefficient bn, and for half range bn is given by this formula, 2 by pi integration 0 to pi f of x sin nx. Okay, let us put value of f of x. Sorry, this is bn. Again जसं आपण previous example मध्ये केलं, as our 0 to pi is divided into two parts, 0 to pi by 2 and pi by 2 to pi, we also break our integral into two parts, 0 to pi by 2 plus pi by 2 to pi. When interval is 0 to pi by 2, when x lies between 0 to pi by 2, function is given to be x. So accordingly value of f of x is x into sine nx as it is, no change, dx. And in this interval pi by 2 to pi, when x lies between pi by 2 to pi, f of x is given to be 0 for this range. So function is 0. Actually no need to write this sign because integration of 0 is 0. You can in fact neglect the second integral. So again neglect the second integral, concentrate only on first integral. So let me add one more page. Okay, so now value of bn, value of bn is equal to 2 by pi integration 0 to pi, in that case f of x is equal to x into sine nx dx, and second integral is 0 now. Okay, let us evaluate this integral. Again integration by parts. Again this is first, this is second, because derivative of x vanishes early. Derivative of x is 1, then derivative of 1 is 0. So therefore ज्याचे डेरिव्हेटिव्ह लवकर 0 होतील त्याला आपण फर्स्ट घेतो. फर्स्ट ॲज इट इज इंटिग्रेशन ऑफ सेकंड, साईनचं इंटिग्रल मायनस कॉस एन एक्स अपॉन एन एक्सचा डेरिव्हेटिव्ह एन. ओके, नाव दिस इज फर्स्ट, दिस इज सेकंड, अल्टरनेट प्लस मायनस. नाव मायनस पहिल्याचं डेरिव्हेटिव्ह एक्सचं डेरिव्हेटिव्ह 1 अँड इंटिग्रेशन ऑफ सेकंड मायनस ॲज इट इज इंटिग्रेशन ऑफ कोसाइन is sine nx upon n, that n and previous n into n becomes n square. Next derivative of this one becomes 0, so further terms becomes 0, so we do not write further terms. This integration has lower limit 0, upper limit pi. Let us put up the values. We get bn 2 by pi. When we put x is equal to pi, okay, sorry, small mistake here, integration from 0 to pi by 2. 0 to pi is whole interval. Now it is divided into two parts, 0 to pi by 2, f of x is x. For pi by 2 to pi, f of x is 0. So wrongly I have written pi here. Okay, now let us put upper limit first. When x is equal to pi by 2, this minus sign as it is, cos n x is equal to pi by 2, so it becomes cos n pi by 2 divided by n, minus minus plus, so plus sign, multiplying by 1, it is identity, so forget it. Sin n x, sin n, and x is equal to now upper limit pi by 2, denominator is n square as it is. And when we put lower limit 0, this x 0 makes first term 0, and when you put x is equal to 0 in second term, there is sin nx term, so sin 0 is 0, which makes second term also 0. So lower limit 0 टाकल्यामुळं ह्या x मुळे पहिली टर्म 0 येते आणि साइन मुळे दुसरी पण टर्म 0 येते. सो फॉर लोअर लिमिट we get 0. So this part is upper limit minus this part is lower limit, upper minus lower. Okay, now let us simplify this. So final answer is 2 by pi. In fact, cos n pi by 2, it depends upon value of n, whether it is even or odd. Similarly, sin n pi by 2 also varies according to your n, even or odd. Okay, so let us keep this as it is, minus pi by 2 cos of n pi by 2 upon n plus sine of n pi by 2 upon n square. This is the value for bn. We can find out few values for n equal to 1, 2, 3. Accordingly, for n equal to 1, 2, 3, let me show you few values of b1, bn. When you put n equal to 1, b1 is equal to 2 by pi minus pi by 2. Now you put n equal to 1, cos 1 pi by 2, cos 90. Cos 90 is 0. So when you put odd values of n, 1, 3, 5, cos 1 pi by 2, cos 3 pi by 2, let us show like this: 0 degree, pi by 2 radian, pi, 3 pi by 2. This pi is actually 2 pi by 2, means even multiple of pi by 2. That's why 2 gets cancelled. जर n pi by 2 मध्ये n हा even number असेल, 2 will divide it, so we get multiple of pi. Okay, so multiple of pi means this is 1 pi, 2 pi means again 0, 3 pi means again pi, 4 pi means again 0 or 2 pi. Okay, so even multiples gives you either cos 0 or cos pi, pi, 3 pi, 5 pi, 6 pi. Okay, like this means accordingly you can find its value. And odd multiples of pi by 2, cos 1 pi by 2, that is cos 90. Cos 90 is 0. Cos 3 pi by 2 is negative 0, means again 0. 5 pi by 2 again 0. 7 pi by 2 again 0. So for odd multiples of pi by 2, 1 pi by 2, 3 pi by 2, 7 pi by 2, cosine term becomes 0. And in that case, sine terms takes alternate plus minus 1. For sine, sine 90 is 1, sine 3 pi by 2 is minus 1, sine 5 pi by 2 is again plus 1, sine 7 pi by 2 again minus 1. So for n is equal to odd, cos term becomes 0, only we have to take care of sine term. Okay, and reverse, when n is equal to even, sine multiple of pi becomes 0, sine term becomes 0, we have to only consider cos term. Okay, so to find b1, odd multiple of pi by 2, then cos becomes 0, cos pi by 2, cos 90 is 0, so first term becomes 0, and sine 90 is 1 upon n square as it is. So you can write like this, sorry, n is equal to 1 also, n is equal to, we have considered 1, so n square means 1 square, 2 by pi into 1 upon 1 square, or you can simply say that 2 by pi only. This is value of b1. To obtain b2, n is equal to 2, even number. In case of even number, n 2 divided by 2 gets cancelled, sin pi is 0, so now sine term becomes 0 and cos term survives. So 2 by pi minus pi by 2, when you put n is equal to 2, cos 2 pi by 2 means simply cos pi, and cos pi is minus 1, starting with minus 1. For even numbers 2, 4, 6, this cos becomes alternate, minus 1 plus 1, again minus 1 plus 1. It will take alternate plus minus 1. Okay, cos pi is minus 1. Cos 2 pi means same as cos 0 plus 1. Cos 3 pi again minus 1. Cos 4 pi again plus 1, like that. Upon n means n is equal to 2. So let us simplify this. Value of b2, this pi gets cancelled. Negative, negative, you will get positive number. 2 upon 2 into 2, 4, that is 1 by 2. So likewise you can obtain further values. Okay, so for odd numbers n equal to 1, 3, 5, cosine term becomes 0 and sine term will give you either plus 1. In next b3 it is minus 1. For b5 again plus 1, b7 again minus 1, alternate plus minus 1. Okay, so this is how you can obtain values of bn, and by putting them in Fourier series you can easily obtain remaining Fourier series in terms of sine function. This is it. Let us stop here. Thank you.